الله الرحمن الرحيم. أعزائي طلبة وطالبات شهادة الثانوية العامة قسم رياضيات لغات، السلام الله عليكم ورحمته وبركاته. اليوم سنتناول مراجعة عامة على الوحدة الأخيرة أو يونت 6 في مادة الاستاتيك. طبعا Center of Gravity and Negative Mass very important unit to calculate more examples about any exam. Welcome, my dear student, in our math program for secondary 3. Today we are taking new revision about Unit 6. Unit 6 about Center of Gravity and Negative Mass. My dear student, Center of Gravity, very important unit to calculate more example about any exam. My dear student, look at revision about Center of Gravity. ABC is triangle, AB 6 cm, BC equal 8 cm, CA equals 10 cm. D and E are midpoints of AB and AC. Then 3 equal mass, each of them is M, are placed at point D, and point E. Find the center of gravity of this mass. Look at solution. We have, my dear student, 3 masses are equal, each one is M. At point B, at point D, at point A. Also, we have D is midpoint of AB and E midpoint of X, Y, or between A and C. Point lie on X is C, point lie on Y axis at A. Therefore, E is midpoint. First, find the midpoint of E equals 4, 3. Why? Because x1 plus x2 over 2, y1 plus y2 over 2. Point D is midpoint of AB equals 0, 3. My dear student, CA equals 100. Y 6 power 2 plus 8 power 2 under square root equal 10. CA square equal 100 equal AB power 2 plus BC power 2, therefore equals 100 centimeter square. ABC is right angle triangle at B. Let B origin point. BX, BY, 2 orthogonal at B. Point B is origin point. Therefore, point A 0, 6, point C 8, 0, point D midpoint 0, 3, point E 4, 3. How many forces? We have 3 forces. Act at D, acts at B, acts at E. Then it's better to form following table to represent the mass and coordinate of each. Look at the table. The first at B, at D, at E, first row. First column represent mass. At point B, M. At point D, also M. Also at E, M. X coordinate at B, 0. At D, 0. At E, 4. Y coordinates at B, 0. At D, 3. At E equals 3. By using the rule XG equal what? M1 x1 plus M2 x2 plus M3 x3 over summation of 3 mass. Therefore, XG equal 4 over 3 centimeter. By using the same method, YG M1 Y1 plus M2 Y2 plus M3 Y3 over summation of all mass equals what? 2 centimeter. Then the center of gravity, its symbol G, 4 over 3, 2. The first coordinate 4 over 3, second coordinate 2. Another example. 4 equal mass each of 200 grams, are placed at the vertices of square ABCD. Determine the center of gravity of system, and if the mass placed at C is removed, determine the center of gravity of remaining system by using negative mass method. Look at solution. We have 4 forces, 4 mass, each one 200, act at A, B, at C, at D, each one 200. Let E the center of the square. We know that center of gravity of shape or lamina as square is intersection point of its diagonal. E center of square. And the square side length equals L. We suppose let AX and AY two perpendicular directions. And E and A is the origin point, 0, 0. We form the following table. Remember, my dear student, point D at distance L0, but point B 0L. Point C LL. Look at the table which represent center of gravity. The first row for points A, B, C, D. The first column represent the mass at A 200, at point B 200, at point C 200, at point D 200. X coordinate, point A 0, 0, 0 on X, 0 on Y, but B 0 also, but CL, DL. Y coordinates at point A 0, at point B L, at point CL, at point D 0. By using the rule, to calculate the center of gravity, M1x1 plus M2x2 plus M3x3 plus M4x4 over 800. Look at xg equals 400 L over 800 equal half L. This coordinate of xg. By using same method, yg equals y1 x1 plus y2 x2 over summation plus y3 x3 plus y4 x4 over summation of all mass m1, m2, m3, m4. Therefore, equals 1 over 2L. Then the center of gravity is half L and half L. At point E, which is center of square or intersection point of diagonals. After removing the mass 200 excited at C. Therefore, look at, we have at C, we removed the mass at C. This is negative mass, negative 200. We form a table. They are mass at E 800, its center or coordinate at E L over 2 and L over 2 at C, negative 200 the coordinate of point C, L and L. We form a table, has 2 mass and 2 coordinates. The mass at E 800, at C negative 200. X coordinate at E L over 2 at C L, but Y coordinate at E L over 2 at C L. By using the same rule, M1 x1 plus M2 x2 over summation 800 plus negative 200, 600. Therefore, xg dash 800 times L over 2 minus 200 times L over 800 minus 200 equal third L. Y G dash by the same method, M1 Y1 plus M2 Y2 over summation. Therefore, Y G dash equal third L. Then we know that G dash equal third L and third L with respect to the point A. Another example. ABC is equilateral triangle. Side length 30 centimeter. D is midpoint. D is point intersection of each median. E is midpoint of BC. Mass of magnitudes 20, 40, 30, 60, 50 grams are fixed at points A, B, C, D, E respectively. What do you mean respectively? 20 at A, 40 at B, 30 at C, 60 at D, 50 at E. Identify the center of gravity of this system. Look at, then where does the center of gravity of remaining system lie with respect to the vertex C if the mass excited at B is removed? Solution. We know that, or we take or suppose CX, CY two perpendicular direction and C is the origin point. C is the vertex of one of vertices of A, B, and C of triangle. CX, CY. C represent origin point. The force or the mass 30 at C, at D 60, at A 20, at B 40, at E 50. From the figure we get AE equals 30 sine 60. Why? Because triangle ACB is equilateral triangle, means AC inclined with CB with angle 60, AE equals 30 sine 60, or 30 times root 3 over 215 root 3 centimeter. Also DE, third median, third 15 root 3, AD. DE, AD 2/3. DE, third median, AD 2/3, 5 root 3 centimeter. We form the following table. A, B, C, D, and E. This point which mass act on it. The mass at A 20, B 40, C 30, and D 60, also E 50. X coordinate at A 15, at B 30, at C 0, origin point, at D 15, at E 15. Y coordinates 15 root 3, 0, 0, 5 root 3, 0. By using the rule, xg equals m1 x1 plus m2 x2 plus m3 x3 plus m4 x4 plus m5 x5 over summation equal 15 and 3/4. By using the same method to calculate yg, therefore coordinate 3 root 3, the center of gravity of the system, its symbol G, 15 3/4 and 3 root 3. After that, my dear student, we removed the mass at B, negative 40. After removing the mass 40 gram exists at B. Therefore, we form table G and B. Mass at G 200, but at B negative 40. X coordinate at G 15 3/4, at B 30. Y coordinates at G 3 root 3, but at B 0. By using the same rule, m1 x1 plus m2 x2 over summation between m1 m2. Therefore, xg dash 12 and 3 over 16. yg dash by the same method equal 15 root 3 over 4. Then the center of gravity of system after removing the mass 40 gram is g dash. Its coordinates 12 and 3 over 16. Second coordinate 15 root 3 over 4. My dear student, if the friction force equals 25 Newton and coefficient of friction equals 5 over 12, then resultant reaction equals, choose the correct answer, 60, 65, 70, and 75. Look at, my dear student, at the first, in this case 25, this is equal mu n, 5 over 12 Newton, 5 over 12 n. N reaction force equals 60, but R dash, we know that equals n square root 1 plus mu square. N equals 60. Resultant forces equals 60 multiply square root 1 plus 5 over 12 for all power 2 equals 65. Remember, my dear student, R dash represent resultant reaction equals R or N multiply square root 1 plus mu square. Look at, my dear student, a uniform ladder of weight 20 kilogram rests in vertical plane with one end on a rough horizontal floor and the other end against on smooth vertical wall. Remember, my dear student, there is difference between rough plane and smooth vertical wall. What's the difference between them? The smooth vertical wall reaction is perpendicular to vertical wall, but in rough plane the reaction has two components on x and y axis. In this example, we have uniform ladder of its weight 20 kilogram rests in a vertical plane. Uniform ladder means its weight 20 kilogram act at midpoint. The one end of rough horizontal floor and the other against to smooth vertical wall. The ladder is inclined at 60 degrees to horizontal. Given that coefficient of friction between the ladder and the floor equals 1 over 2 root 3. What is required? Prove the maximum distance a man of weight 60 kilogram can ascend up the ladder is equal to half length of the ladder. Look at solution. We have AB is a ladder. Ladder inclined with horizontal with angle 60. We have rough plane on at AC has reaction RA and or R reaction and mu R2 or RA and 1 over 2 root 3 R2. And the ladder one end at B on smooth vertical wall. What do you mean? The reaction perpendicular to the wall. At the first, we let length of ladder is 2L. Vertical, we have RA equals 60 plus 20. Forces up equal forces down. R reaction at point A equals 80 Newton. Horizontal reaction at point B equals 1 over 2 root 3 reaction at A. We know that reaction at A equal 80. We multiply 1 over 2 root 3 multiply 80 equals 40 root 3 over 3. This reaction at B. Remember, my dear student, the moment about A must be equal 0. Then 60 times x cosine 60, this is the moment we have three forces, 60, 20, and reaction at B. 60 times x cosine 60 plus 20 x times the distance L cosine 60 minus RB times the distance to L sine 60 must be equal 0. To calculate reaction at A, therefore moment at A equals 0, 60, the force or the weight of the man 60 multiply the distance between or perpendicular distance from A equal x cosine 60. The ladder its weight 20. What is the distance between the midpoint of the ladder and the point A? Equals L cosine 60. Therefore, to calculate the value or relation between x and L, therefore 30x plus 10L negative 40 root 3 over 3 times 2L times root 3 over 2 must be equal 0. We have equation into unknown, x and L. We must find the relation between x and L. Therefore, my dear student, 30x plus 10L minus 40L equals 0. Or 30x equals 30L. What you mean? X equal L. Therefore, when a man ascends the ladder, this man, its weight 60 kilogram. The distance when a man ascends the ladder at a distance equals half ladder, its weight 60 kilogram. 60 kilogram, this is the weight of the man. When ascend the ladder, must be ascend the half length of the ladder. Remember, my dear student, in this example, a ladder AB inclined with vertical, with horizontal, with angle 60. We have reaction at point A. We have reaction at A and mu RA. What is the mu? From given 1 over 2 root 3. But reaction of vertical wall is at point B are be perpendicular to the wall. Why? Because this the wall is smooth vertical wall. We know that the reaction among vertical smooth wall must be perpendicular to it. Therefore, my dear student, this very important reaction of smooth must be perpendicular, but reaction of rough not perpendicular. We resolve it into two components, one horizontal, second vertical, to calculate reaction as a hang as the end of the ladder and so on. This very important to calculate reaction of the force or magnitude of or the measure of angle which inclined ladder with x-axis or on y-axis or on vertical wall. My dear student, this example represent how to find the moment about point A. We must note that direction of moment positive or negative. Positive direction, anti-clockwise, negative direction, clockwise. My dear student, by the end of the lesson, we know that center of gravity and negative mass, very important lesson. Moment also about a point in 2 directions or in 3 directions, very important to calculate it in any exam. My dear student, I am very happy to spend such time with you. Thank you. Goodbye.